In today's video, we are going to look at recursion. More specifically, we are going to look at functions calling themselves, which is the essence of what recursion is. So we are going to look at what the recursion call stack is and how it helps us in recursion, and what a base case is and why we need one. So let's dive right into an example. Over on the left, I have a function that doubles a number. So double of 2 is 4, double of 15 is 30. And how does this work? Well, first I start by calling double of 3. And if we look at the function, n is not 0, so it does a recursive call. So it calls double n minus 1, and it adds 2. So we get a plus 2 in the end. So we are now calling double of 2, and double of 2 does the same thing because n is not 0, so it adds plus 2. Then double of 1 is not 0, so we add plus 2. And then once we hit 0, 0 is our base case, which means we are finished doing recursive calls, and now we go back up what's called the call stack and sum up our values of 2. So we get 0 plus 2, 2 plus 2, 2 plus 2 plus 2, which gives us our answer of 6. And now we have effectively recursively doubled 3. Let's look at another example. Suppose we want to recursively compute the value of b to the power of e, or the base to some exponent. Some examples include 2 to the power of 3 and 3 to the power of 5. We just multiply by the base an exponent number of times. So what is our base case? What do every exponent fall back to? Well, our base case would then be b to the power of 0, where when the exponent is 0, that's when we should stop. An example is, suppose we have 4 to the power of 3, then when doing our recursive calls, we are essentially chopping off an exponent every time and then multiplying by 4. And so as we're breaking down 4, eventually we'll get to 4 to the power of 0, which is 1, and then that'll cause our multiplication to stop, or rather our recursive call to stop, and we multiply all our 4's together. So we would implement it like this. Exponentiate some base, some exponent. Our base case is when our exponent is 0, then we return 1, and then we do our recursive call. So we do the exponentiation, and each time we call the exponentiation, we subtract 1 from the exponent and multiply by our base. So if we call exponentiate 2 to the power of 3, then we would get a multiplication by 2, because that's what our base is. And then we would exponentiate 2 to the power of 2, because we did a recursive call. And then we would keep exponentiating until we reach the base case, which is when our exponent is 0. And once we've reached this point, the call stack unwinds once again and climbs back up. So we get 1 multiplied by 2, 2 multiplied by 2, 2 multiplied by 2 multiplied by 2, which gives us our desired result of 8. So in this video, we looked at basic function recursion. Recursion is a tough topic, so we are going to look at a bunch of examples in the next video. See you then.